So since I said that SQL injection was what we thought it was, we said, well, let's look for all select queries in the source code. So we created a regular expression that you see up there and ran the equivalent of grep searches through the source code base, trying to identify all places in the application code base where a raw SQL query was embedded, where there was no stored procedure call, but an actual select query was in place. Anyone want to guess what the results were? It's up there, overwhelming.
Overwhelming.
They were literally t-shirt. Okay, sure. That answer deserves a t-shirt. Overwhelming. Who said t-shirt? Okay, I'm going to ask you guys to pass it back on to him. So, given the fact that we had an overwhelming number of hits for select kind of queries, we already knew that this application didn't really follow best practices in accessing the backend database. But then we said, well, let's make our search a little more granular. Let's look for select star kind of queries. The kind of queries which are possibly most susceptible to such attacks because they yield the most information. They yield every single column of the database. So we ran that and we found exactly 5 hits. So that was pretty good. Overwhelming to 5. From those 5, we started looking at them, and what we found was one was select star from card table. Obviously, I changed the name of the table there. But it was a select star query which accessed the credit card database. We actually went to the line in code there, which was ASP code, and we looked at it. Now, I am definitely going to give away a t-shirt and a ping pong ball to someone who tells me what's going on here. Come on. Someone read the slides on the CD already. No, kidding. Right. Now that's a good answer. I'm going to request you guys to pass this back to him. I'm going to see how far I can throw the ping pong ball. I got it pretty good. So he picked it right. It was a developer backdoor. If you look at that code there, what it does is it looks for a parameter which it terms as extra, which is already a giveaway. So what it was looking at was the URL, pulling out all the parameters from the URL, and there was one additional parameter, the 5th parameter, and if the 5th parameter's value was equal to let me in, then well, do a select star query and actually display the results of that back to the end user. So it definitely seemed like an insider job. Someone created this additional parameter so they could keep coming back and viewing what was going on. Now, was it an insider job? We started talking to the guys and we figured, well, they had outsourced much of their application development to some third party in Asia.
We'll let you guess which country.
No, it wasn't India. So we started looking at the code archives to detect addition of this particular code. We wanted to look at the different version numbers that were actually checked in to identify which particular version had this piece of code and who had checked it in. We went through that. We were lucky we found the user ID that was used, but it was a generic user ID that was used by this third-party provider. Well, now that we had this information, we went back to the web server logs and said, well, on first attempts to look at it, we didn't see any SQL injection, we didn't see any of that. But what we know is that if we find this 5th parameter in one of the requests, there is something fishy happening there. So we actually used log parser once again to pretty good effect, identified all the requests that had this additional parameter in them. Guess what? It came from an IP address in Asia, the same country. It could well have been a proxied session, but the fact that we found that the developer from that country, and then we see an IP address from the same country accessing that 5th parameter, he wasn't probably smart enough to proxy through a proxy in the United States, maybe. Exactly. That's what I want to tell him.
Yeah, the big thing. Yeah, the big thing in this case really was the check-in, the being able to trace it back to the development company, and they were able to kind of know who had been working on the code at that time and figured it out for the most part from that. I mean, it definitely gave us some more just to be able to kind of convince the management at that company that it was them when we had the IP address.
Yes.
That wasn't this case. That was the previous case study.
No, he was talking about the snail mail. We'll discuss that offline. But the fact of the matter was, again, we thought about the proxy case, but what happened here was just given the country this person was coming from, he probably did not care if his IP address was shown in the web server logs. He knew there was no way to get a hold of him or her. He was proved to be wrong because the development company was notified of this rogue activity. The local law enforcement was roped in. And believe you me, they were actually cooperative in this case. They actually did get a hold of the person. Yes, so we were actually able to successfully halt this attack. And actually, law enforcement was from the US side as well involved in this, just to go back to your question there. Just didn't want to give it away right now. Because there was no way we could have got cooperation from local law enforcement in that foreign nation without their help. Yes?
All the customers were notified, right?
That's above our pay level.
Yeah, all I'm going to say is that wasn't my decision to make.
Yeah.
I was lucky.
When was U.S. law enforcement involved?
They were involved pretty early on in the case, but late enough that it allowed us to perform some initial forensics by ourselves. We walked out of the case. We don't know what happened.
How much time elapsed? Your 72-hour clock.
Oh, we were actually getting pretty close to the 72 hours, but we were actually able to understand this attack prior to that. And like I said, because local law enforcement was cooperative, we were able to prevent this attack from taking place. Otherwise, you'd have seen it in the news. Not to say that you've not seen 15 other similar attacks. It might have been one of those. They made initial contact by snail mail to kind of prevent detection via electronic means. They did not want to send emails and have them traced back. What was interesting, I guess I missed it on one of the previous slides, was they said if you are agreeable to our terms or not, you need to specify that on the main web page in small font right at the bottom. So what another technique would have been, had the 72 hours lapsed, we would have monitored every single IP address potentially hitting the main page. But given the fact that it was a large retail organization, there's millions of IP addresses that hit this page. So I guess going into the post-mortem, what could have been done better? And there's a lot of different answers. That's definitely not a comprehensive list up there. Some of the things that could have been done better was if there was encryption of sensitive information. This is what I was telling Chuck yesterday, but he disagreed with a valid point, saying the fact that if there had to be a way to decrypt it, and if it was a developer insider job, he probably knew what algorithm, what key was being used to encrypt it, so he could have decrypted it as well. So in this case, probably it wouldn't have held true, but definitely encrypting cardholder data, which is now a requirement by the PCI, Visa guys, definitely that was that would have been one of the countermeasures in normal circumstances. More advanced database logging, that complete database logging didn't really help us. The login, logout activity. Anyone have any suggestions as to how that can be enhanced? How can you enhance database logging on a Microsoft SQL server? Use a third-party tool. Is there any other way to do it without me having to spend money after I've already drained my pockets out on Microsoft? I heard triggers. Stored procedures, triggers, server-side traces. Sure. Very valid point. How could you do it without impacting the performance of the database? And just hold on, we'll discuss this in the next couple of slides as to what the different options are. A lot of the security folks would have walked in and said, C2 auditing is your answer. I disagree on that because it would impact performance to a level where the retail organization might as well not do e-commerce. But also one of the other yes?
Well, the one thing that I've seen is there was a select all query to the card table, and I would think that type of request from the application shouldn't be a valid request.
Right.
Why would you want an outside query to your entire table where you're sensitive?
That's a good point he brings up. Why would you want a select star kind of query? That should kind of light up the alerts as well. And that's exactly the third bullet point there. If there was comprehensive code review there performed from a security standpoint, they would have caught those select star queries and said, this does not look legitimate. Or even if it were legitimate, this is not best practices. So from that standpoint, I thought in this case, a combination of reviewing the source code as well as performing a little more advanced database logging just rather than log in, log out activity would definitely have helped to prevent the attack. Yes?
Did you review their other applications for similar issues?
Well, yeah, we kept ourselves busy for a while. I'll leave it at that.
How would your encryption of the database work when more than likely the application request will be valid and it would be encrypted?
That's right. That's exactly the point I brought up. In this case, probably encrypting the sensitive information would not have helped, since it was almost a backdoor within the code. A developer would have known the algorithm and the key to decrypt the information. I'm sorry? I did actually modify the code to make it a little more obvious. The value of the parameter was not let me in, and that's the reason we were kind of banging our heads against the wall trying to figure out what was happening. Yes. That's correct as well. It would have worked if that was the case, if they didn't really need to, yeah, exactly. Oh, absolutely. That's always an option these days. They fell off the truck, some consultant walked in, made a copy on his laptop, his laptop got stolen, lost his laptop. Those are very viable options. Yes?
Have you also tried looking at the parsers and developing, so you do a lot of incident
Right.
response, and you might start to see a repeat of the same type of attacks.
Right.
Would you link your parser with something that would say, I'm looking for these known type of events?
Yeah, I actually have, I'm in the process of converting it to a batch script right now, just for the fact that I don't really have time to make it fancy. But I've come up with the regular expressions to look through ASP source code at this point, which kind of identify flaws similar to this, or even not backdoors, just poor practices, related to session management or SQL injection, or cross-site scripting, etc. And we can definitely talk about that. So, security reviews of code would have helped. Advanced database logging. The one I'm going to discuss here a little bit right now is what the options from a database logging perspective were. Like I said, the common databases by default really do not enable much logging, and for a valid reason, because it hits performance pretty badly. And most of them have, especially Microsoft SQL Server has the all or nothing option. Most of the time people are like, is it C2 or is it just log in, log out? And like I said, a lot of people will say, well, let's do, C2 auditing is the way to go. And there are some advantages to it for sure. The fact that it records a whole bunch of information, if there is a potential attack, there is a high probability, definitely higher than the default Microsoft SQL Server logging enabled, that you will detect the attack if you have C2 logging turned on. These logs are normally stored in tracefiles.trc files, which fill up, and once they're 200 megs in size, it creates a new file, I believe. So they can be viewed by using SQL Server Profiler, and there's a lot of people out there who say that's the way to go. Like I said, it has a bunch of disadvantages which from a business standpoint don't make any sense to enable it. Performance is hit if it stores stuff in the same directory or the same disk as the SQL Server is resident on. If the disk gets full, the SQL Server stops responding, which is a requirement of C2. It's a fail-safe requirement. You definitely don't want that in a commercial environment. So what I've used C2 auditing as, it's not a practical long-term auditing solution, but what I've seen it used effectively for is as a short-term option when responding to an ongoing incident. When you know that there is an ongoing incident, it might not be a bad option to